Hello, thank you for watching this video. So on this video, I'll be doing question 8 of November 22 question paper, mathematics paper 1. So I'll read the question statement and then answer the questions that follow. So here's the diagram. So question 8 read as follows. The graph of y, which is a derivative of some function f, is drawn below. The graph passes the points P, Q, and R. Let me read the statement again. The graph of y, which is a derivative of some function f, is drawn below. The graph passes through the points P, Q, and R. So, if we look at this, we are given this equation, this form of equation. We are told that it belongs to this graph here, right? So this graph here is the derivative. It is the derivative of some function f. That's what they're telling you. And you are told that it passes, the x-intercepts are P and Q, and the y-intercept is R. That's what you're given. You're given the intercepts, all of the intercepts. That's what they give you basically. And you are given their coordinates as well. And you're told that this equation is in this form. That's what this question is basically saying. So let's continue. I'll read the questions now. Determine the values of m, n, and k. So they want you to find the values of m, n, and k. That's what they're asking you to find. So m, n, and k. So m is the coefficient of x squared, n is the coefficient of x, and k is the constant, which is the intercept. That's what they want you to find. So to do this, there are many ways you can approach this. But if you are given the intercepts in one point, you can use, you can find the equation of, you are given the intercept, the two intercepts of a parabola, right? So now you know how to find the equation of a parabola if you are given the intercepts in one point, at least one point. So that's what you're going to do here. So we are given the x-intercepts, Q and P, and 1 point, which is also an intercept, which is the best case scenario. So just find the equation of a parabola, then you know what your y values are, your m, n, and k values are. So you say, okay, y is equal to a times x minus x-intercept 1 times x minus x-intercept 2. So you use this formula to find the equation of a parabola when you're given the intercepts. This is the first x-intercept and this is the second one. And then you use the point, third point that you're given to find the value of a. That's what you do basically here. So you say, okay, y is equal to a times x minus x-intercept 1. My x-intercept 1 can be this one or this one, but I'll take it to be that one. Which will be x minus x-intercept 1 minus 1 over 3 times x minus x-intercept 2, which is 1, right? So what do we have? We have a times x plus 1 over 3 times x minus 1. This is what you have. So you have something similar to this, but the problem now, it will be that value there. So you need to find what the value of a is. That's where the third point comes in. So you have r there, which is r is 0 and 1. So you know this is your x and the y coordinate. So you put your y there. Y is equal to a times 0 plus 1 over 3 times 0 minus 1, right? Then just punch this in your calculator. What do we have? You have 1 is equal to a times this is minus 1 over 3. And then you divide by minus 1 over 3, divide by minus 1 over 3. So a is equal to minus 3. That's the value of a. So now that you have your a, you put it back here and expand this entire thing. So you say y is equal to a, which is minus 3, times x plus 1 over 3 times x minus 1, right? So you expand this. So it's minus 3 times this, times that. You do the thing. So you find you have x squared minus 2 over 3x minus 1 over 3 when you expand that. So you simplify this further. This times this. What do we have? You have minus 3x squared plus 2x plus this times that plus 1. So you said your equation was what? Was f prime at x is equal to mx squared plus nx plus k, which means your m is this one, your n is this one, and your k is that guy. So your m is equal to minus 3, your n is equal to 2, your k is equal to 1. Those are the values of m, n, and k. This is how you do this one. So I hope it is clear. We'll go to the next question. So I'll clean the board now and move to the next question. Okay, so we'll go to 8.2. It is further given that f of x is equal to this equation here. So which means we are given that the equation of your original function of this guy is minus x cubed plus x squared plus x plus 2. So what you're given here, which is this, it is the derivative of this guy. That's what they're telling you. So you can also verify these values by deriving this. That's also something else that you can do. So you are given the original function f. This is what they're telling you, that the equation for the original function of this derivative here, because what we have here is f prime, which is the derivative of f, and this is f. That's what they're telling you. It is further given that f is this equation here. So go to 8.2.1. Determine the coordinates of the turning point of f. So they want you to find the coordinates of the turning point of what? Of f. That is what they want you to find. They want you to find the coordinates of the turning point of this function. So how do you do this? You know that the first derivative of a function is giving you the gradient of a function in each and every point. So at x is equal to minus 1 over 3, you got if your x is equal to minus over 3 on your function, right, its gradient will be 0 at that point. This is what this tells you. If your x is equal to 0 on your function, on this graph of f, then its derivative is 1. Its gradient is 1. If your x is 0 on your original function, its derivative there is its gradient is 0. So this is a gradient function. It tells you the gradient at each and every point of your function. So when you see it here, you see what you see here? You see the maximum gradient, which means your graph will have the biggest possible gradient at this x value here, whatever this x value is. So you have the maximum x value, maximum gradient at this point. So this is a gradient function of what? Of this function. So we know that our cubic function, this one, have two turning points, right? And at the turning point, the gradient is 0. That's what you know. You know at the turning point, the gradient is 0. So which means if this is your gradient function, where this graph is 0, that's where your turning points are, because that's where the gradient is 0. Because this is a gradient function. And it tells you that at this point and this point, your gradient was 0, because these are the gradient values of the original function. So now, if you're saying, okay, these are gradient values, which means this is where the turning points were, because at the turning point, the graph is stationary. So there's no movement. The gradient is 0 at the turning point. Tangent the horizontal. Which means you know the x-coordinates of the turning point. So the x-coordinate of the turning point, one of them is -1/3. And the second x-coordinate turning point is 1. Now that you have the x values, what you need to do is find the corresponding y values for each of those x values. That means f at -1/3, just substitute this on the original equation to find the corresponding y value, called -1/3, right? Cubed plus -1/3 squared plus -1/3 plus 2. Then you punch this on your calculator to find your f at -1/3. So -1/3 cubed plus -1/3 squared plus -1/3 plus 2. You will find that your corresponding y value is 49/27, right? Which is approximately 1.81. So your coordinates of your turning point, first point are -1/3 and 49/27. That's what you have. So you have your x coordinate, your turning point coordinates, right? You have that, you have -1/3 and 49/27. These are the first coordinates. Then you need to find the second coordinates, which means you have your second x coordinate, find it there. So f at +1 is equal to -1 cubed plus 1 squared plus 1 squared plus 1 plus 2. And then you punch this in your calculator and find this, and this go away. You're left with 3. So your coordinates are 1 and 3. This is what you have. So your second x coordinate are what? +1 and 3. Yes. So these are the coordinates of your turning points on this function. Okay. Second point, draw. So let's read the second point, second question. 8.2.2. Draw the graph of f to draw the graph of f. Indicate on your graph the coordinates of the turning points and the intercepts with the axis. So they want us to draw this function here. They want us to show the turning points, which we have plotted, which we have found already, and they wanted us to indicate the coordinates of the intercepts to the axis. So we know. Okay, so let's find the intercepts, which is 8.2.2. So let's first start with the easiest one, the y-intercept. So when our function intercepts the y-axis, so when our function intercepts here, which is it cuts or crosses this axis, we know the corresponding x value is 0. So we know that the corresponding x value will be 0, right? We know x value for sure that it's 0. So what that means, we're going to substitute our 0 on our original equation to find the corresponding y value. So f at 0 is equal to -0 cubed plus 0 squared plus 0 plus 2. Then you punch this in your calculator, you'll find that f at 0 is equal to 2, which is the coordinates for the y-intercepts are 0 and 2. This is what this tells you. So you have your coordinates there, your intercepts. Your intercepts, you have 0 and 2. That's one point that you have. Now, you need to find what? The y-intercept. So, to do this, we say, okay, the x-intercept. To find the x-intercept, we know the corresponding y value is 0. So, which means we substitute our 0 there. So, we want our function, our equation to give us 0 there, which is this, which is now f of x is equal to 0, which is called negative x squared, x cubed plus x squared plus x plus 2. So, this is what you have. So now, what you need to do now is to factorize this, right? So to factorize this, you need to first find the factor of what? Of 2, right? You need to find the factor of this, of 2. And, to factorize this, you need to find the factor of this equation, such that it gives you 0, which is at least one solution of this equation using trial and error. I'll say that's what that is. You need to find one factor of this equation, one solution to this equation, one root of this equation, such that it gives you what? It gives you 0. And then from there, you can continue factorizing further using synthetic division or long division. I like long division. Okay, so to do this, you say, what are the factors of 2? The factors of 2 is 1 and minus 1 is 2 and minus 2. So these are the factors of 2. So what you do, you substitute them here on your equation to see which one of these factors will give you 0. So which means you have this minus this squared factor plus factor squared plus factor plus 2. So you want to see which of these factors will give you 0, because you hope at least one of them will work, one of these 4 factors. So the first thing that you do, you say, okay, this is cubed here. Okay, so you say, I'm going to substitute all of my factors and see which one of these factors will give me 0. So I'll start with 1. So you put your 1 here, 1, 1, and 1 there. And then you substitute on a calculator and punch this on a calculator. So if you put 1, all of it, you get 3, right? Which does make sense because you had this 1 and 3 here. So 1 is not our factor satisfying this equation to give us 0, right? Then you go for minus 1, put minus 1 here, minus 1, minus 1, minus 1. Then you plug there, minus 1 and minus 1. So when you put minus 1, you gotta also get 3 as well. Strange. Yeah, so you also get 3 as well. And then what do? Such as minus 1 does not work. You go for the next one, 2, because you want this to be 0. So you go for 2. So 2, 2, and 2. Hash, substitute 2 on your calculator. 2, 2, and 2. And then now you get your 0, which means when your x is 2, that's when you get your what? Your 0. This is what you want. So punch this, you will see that you get 0. Which means you get this equation of ours, this equation, have a solution at x is equal to 2. Right? So now, we're going to use the long division to factorize this guy, now, this thing. So what do? You say, okay, I'm going to clean this part. So now that we have our factor, we're going to use the long division to factorize this part. So to do this, what I'm going to do, we say, okay, we draw our long division thingy. So we put our factor here, x minus 2, and then you put your equation that you want to factorize inside here. So it's minus x cubed plus x squared plus x plus 2. So to perform a long division, whatever that is here that have a coefficient of x, that had x on it, you divide it by that. So whatever is in the front, if you still have x, you divide it by x. That's what you do. So here you have what? So you're going to divide it by x. So divided by x, you get minus x squared, right? Then you say, your answer, it will multiply both of these things. That's what you do. Just continue repeating this. So this times that, we have minus x cubed. This times that, plus 2x, right? And then what you do after this, you subtract this minus this. What do you have? You have 0. This minus this, what do you have? You have minus x squared. Because should be x squared, this one. Because you said, okay, what do? You said this divided by this, you got minus x squared, this times that, which is this times that, minus 2 plus this and this, plus 2x squared, which is that. So this minus x squared, and then plus 0, because you don't have others, coefficient of x and a constant. Then you subtract this and this, get that, the x minus 0 is x, 2 minus 0 is 2. What do you have? You have this. So now you divide this by x. So minus x squared divided by x. So you have minus x here. So minus x times x. So it's minus x squared minus x times minus 2 is plus 2x. And then you put your 0 there because you don't have anything else. So what do you do? This minus this. What do you have? A 0 here. This minus x. Right? This and this plus 2. So we still have x here. So your x divided minus x. So you have minus 1 here. Minus 1 times that, that's minus x. This times that is plus 2. Then you do the subtraction. This and this goes away. This and this goes away. That's how you know that you've done your long division correctly. It should give you 0 at the very end. So which means now the factorized version of this is that times that. So what you have is, I'm going to clean this part. I think we're happy with it. So I've recorded the intercepts there, so I'm trying to find the x-intercepts now. So now what this is minus, it says, okay, what this says is minus x cubed plus x squared, which is this, plus x plus 2 is equal to 0, right? So the factorized version is x minus 2 and minus x squared minus x minus 1 is equal to 0. This is the factorized version of it. So we know the solution x equal to 2. We want to find this one. So our x, so x minus 2 is equal to 0. Or minus x squared minus x minus 1 is equal to 0. So we know our x is equal to 2, which we already discovered. So we must find this part now. So what is this part? So x is equal to negative b plus or minus quadratic formula. We squared minus 4ac all over 2a. So x is equal to, one, find the two more intercepts because we have 1. So x equal to negative b, which is minus 1, plus or minus square root of what? B squared, which is minus 1, all squared, or minus 4, a, which is minus 1, c, which is minus 1, all over 2a. Our a is minus 1. What do you have? You have x is equal to 1 plus or minus square root is 1. Punch this in the calculator. It's 1 minus what? Minus this and this, which is 1 minus 4, which is negative 3, all over minus 2. So this doesn't have real solution. So you know the nature of roots of this thing are non-real. This have non-real roots. So this have non-real roots. Why? Because the discriminant is less than 0, which is this part here. It is less than 0. So if this part is not defined, it's less than 0. It's not defined on a real line, it's less than 0. That means this thing have no more real solution. You only have one real solution, which is x is equal to 2, which is this equation. Have only one real solution. This one and these ones are non-real. They are complex because of this part here. So now let's try to plot it. So we know that the coordinate, the x-intercepts, it will be 2 and 0. So let's go and write it here. 2 and 0. So we have x-intercepts, we have the turning points. So let's go and draw and plot our function. So I'm going to clean here so that I can have all the space I need. So I have all the information that I need there. So I'm cleaning now. So of course, this won't be drawn into according to scale, but I'll try to show all the important points, the shape, the intercepts, and the turning points. So that's what I'm going to do now. Okay, so I have our y-axis here, which is the line y is equal to 0. Our x-axis, this is line x equal to 0. This is line y is equal to 0, this one. So you have a 0 here. I'll say I have 1 here, I have 2 here, and 3 here, and 4 here. 1, 2, 3, 4. Let's try to find. So I have 1 minus 1, minus 2, minus 3, minus 4. So I have 1, I have 2, I have 3. 1, 2, 3. Let's say 4 also. Say 1 minus 1 minus 2 minus 3 minus 4. Okay. So what do? We plot the values that we have. The turning points, minus 1 over 3, which is minus 1 over 3, minus 1 over 3. It's about 0.33 going forward. So I'll say somewhere, so half is somewhere here. So I'll say maybe it is somewhere here. I'll say somewhere there. So I'll say this is minus 1 over 3 here. This one here. It corresponds to this, which is about 1.8 something. I think I wrote it here. It was about 1.8 something. Say 1.5 is here. So it's here 1.5. 1.8, I'll say 1.8 is somewhere here. So 1.8 is somewhere here. Right? This is your turning point. We're done with this one. Let's go to this one. 1. So this is the turning point. Let me make it a star so that I remember. So you have 1 and 3. 1 is here, and 3 is here. So I'll say this is our second turning point. So have it with the y-intercept at 0 and 2. So it's here, 0 and 2. What else? We have x-intercept at 2 and 0. We have the x-intercept here, 2 and 0. So we know our function, which is it was what? Y is equal to minus x squared cubed plus x squared plus x plus 2 is equal to 0. I think it was something, it was something like this, I think. So you know this thing is negative, right? So it starts coming down and then do the thing. So it starts coming from this direction, 10 here, go through this point, 10 here, then pass through 2, should be something like this. Of course, the shape is not very beautiful, but I think you see the point. This is not a straight line. Yeah, so this is how you plot this thing. So you have your turning points here, your 1 and 3. Here you have your minus 1 over 3 and 49 over 27. So here you have your 0 and 2. Here you have a 2 and 0. So this is how your function looks like. I'm not sure if I'm missing anything. I've plotted the x's, I've plotted the turning points. So we go to the next question. Okay, I'm going to clear the board now. Hopefully this is clear. 8.3. Points, okay. Points E and W are two variable points on the derivative, on the gradient function f, and are in the same horizontal line. So you are told that 2 points E and H are on this derivative function. So you have your E horizontal line and your H. So you have E here and H here. So they don't have to be here. They can be anywhere on this gradient function as long as they're horizontal. Can be these 2 points, can be these 2, can be whatever infinitely many points you can think of. Just take one. So this is what this means. E and H are 2 variable points on the gradient function in the same horizontal plane. So E and H are 2 variable points in this gradient function, and they are in the same horizontal line. H is a tangent to E, so there's some tangent here, H, right? G is a tangent on F prime at W. Oh, this is W. So G is a tangent here. So we have H that is a tangent here, and here we have G that is a tangent here, right? H and G intersect at D, AB. So which means this line continues and this line continues, and they intersect at some point D here, which are the coordinates A and B. This is what this means here. It means that you have 2 points that are on the same horizontal plane, and one have its tangent, and those tangents meet at some point D above here. So write down the value of A. So they want you to find the value of A. So what you need to know is that the turning point here is the axis of symmetry, which means our parabola is symmetrical about this line. So this distance here from this point to that point is the same as the distance from this point to this point. So these distances are the same. So a point here and the point there have similar properties, such that they are at the same distance from the axis of symmetry, both of them, and their gradient will have the same size but different directions. That's what that tells you, which means these 2 lines, those tangents, will have not equal, but the same size of the gradient, right? But it will only be the direction. One will be negative, or one will be positive, and the other will be negative. That's what you need to know. is that these two have exactly similar gradients but different directions. Similar amount of gradient, size, there's a gradient, the magnitude of the gradient is the same, but the sign is different because one is of this positive orientation and one has a negative orientation. So if they have the same gradient, that means if these two have the same gradient, these two tangents, they have the same gradient and they are from the same point, because this is more or less the same point, but on different sides of the slopes. So the rate of increase or the rate of decrease of this one and increase of that one is more or less the actual rate, which is the change, which is the gradient, is the same. So these will meet exactly on this similar position, because this one is increasing at the same rate as this one is decreasing. So they will meet exactly at the exosymmetry. This is what this means. So they will meet exactly on this line, because this is more or less very similar lines, because they have equal gradients but of different signs. So if this gradient here is 4, this one will be -4. So which means now the rate of change in x, the rate of change in y over the rate of change in x will be similar, except the directions will be different. So they should be meeting at the exosymmetry, which is at the midpoint of this guy, which is, you'll say this and this divided by 2, then you'll get that. So it should be the x coordinate. So A, which is 8.3.1. So your A should be the exosymmetry, which is the midpoint between the two parts, which is x TP, which is equal to A is equal to x1 plus x2 over 2, which is -1 over 3 plus 1 over 2. A is equal to this and this. This is 2 over 3, all divided by 2. This is 1 over 3. So our A is 1 over 3. Or you can say x is equal to negative b over 2a. So you found what? This was -3, this was 2, and this was what? 1. Yes. So your negative b is negative of 2 over 2a. What is your a? A was -3. This and that goes away, this and this goes away. We're left with 1 over 3. Or you can derive that further and equate it to 0, because and then solve for x. Find that your a is equal to 1 over 3. So let's go to the next question. 8.3.2. Determine the value or values of b for which h and g will no longer be tangents to f to this derivative function. Determine the values of b for which h and g, which is this, will no longer be tangents on this gradient function. So at this point, they are inverse function, right? They're inverse, so they are tangents. Even at this point here, okay, actually, let me not even go any further. So the trick is, you want this line to always be a tangent. That's what you want. You want these lines to always be tangents, right? But if your b, which is this point, your graph, your b here, which is this value, is below our turning point, that means this graph will no longer be a tangent. It will be going through this guy 2 times. You see, even this one, if the meeting point where these 2 lines are meeting is below the turning point, that means now you have a situation like this, or a situation like this. So this is no longer a tangent, as it is touching twice then. That's what that means, which means now your b, if your b happens to be lower than the x value of the turning point of this derivative function, then that's why you have a problem. But if your b is equal to the turning point exactly, you can have a horizontal tangent. You can have two horizontal tangents there, that will be your horizontal point now will be the same point, if that makes sense. So, because now if your b is this value here, now you have this tangent and this tangent. So, same point, same horizontal plane. So now, what you're going to do, you're going to say, okay, if my b is lower than this y value here, what is this y value here? You get it by saying, okay, I have the x value is 1 over 3. So the y value is going to be y is equal to f prime inverse of 1 over 3, 2 minus 3, 1 over 3 all squared. I'm substituting on this equation here. Plus 2x, which is 1 over 3, plus 1. Then you punch this in a calculator. F prime at 1 over 3 is equal to this. Here's my calculator. That's my calculator now. Found it. So, punch this in a calculator. You have 1 over 3 squared plus 2 to 1 over 3 plus 1. Oh, sorry. So it's minus 3. Minus 3. So this comes out as 4 over 3. So which means here the turning point of this gradient function is 4 over 3. So if the values of b are lower than this, which is there somewhere here, this will no longer be a tangent. You will have these lines cutting more than once, touching the graph more than once, and they are going through this time. So now, if your b is less than 4 over 3, you will have problems. Or if your b is element of negative infinity to 4 over 3. So that's why you're not having problems. This is how you do this question. I think it will make sense. I hope it will make sense. Thank you for watching. Cheers.